Okay, hello Cloud Gurus, and welcome to this lecture. Well, congratulations, you are at the very end of the course. In this lecture, we're just going to wrap up what you've learnt in Section 8. Going into the exam, definitely one of the most important things is to understand how IAM interacts with S3 bucket policies and how they interact with object ACLs. That is worth an awful lot of marks in the exam, so do review that before you go into the exam. Also, this section is very hands-on in terms of exam tips. We will be adding to this section based on your feedback throughout the year. So go ahead and you might just want to watch the summary lectures of each section one last time before sitting your exam. So let's start with AWS Shield. So this is a free service that protects all AWS customers on Elastic Load Balancers, CloudFront, and Route 53. You really do need to have a strong understanding of what Shield protects. So it's those three services, so your load balancers, CloudFront, and Route 53. It doesn't protect you against things like API Gateway or things like RDS or Aurora, etc., etc. Shield protects against SYN UDP floods, reflection attacks, and other layer 3 and layer 4 attacks. And then you can also get Advanced Shield, and this gives you enhanced protection for your load balancers, CloudFront and Route 53 against larger and more sophisticated attacks. It's $3,000 per month, but you will get your own incident response team. And to be honest, for any Fortune 500 company, $3,000 a month is not very expensive. It's probably worth taking a look at. Advanced Shield provides always-on flow-based monitoring of network traffic and active application monitoring to provide near real-time analysis and notifications of DDoS attacks. Like I said, you get a 24/7 DDoS response team. And the cool thing about Shield Advanced is it protects your AWS bill against any higher fees if you are, suffering from a DDoS attack. My DDoS exam tips: understand the two different levels of Shield. This is definitely worth reading this DDoS white paper. I'm actually fond of that DDoS white paper. It was my very first job as an AWS solutions architect to read that white paper and then identify a customer's environment and basically measure their existing environment, how it applies to that white paper and what they should be doing differently. So it was my sort of very first professional task with AWS was around that white paper. Definitely worth a read before going into the exam. And just remember the technologies that you can use to mitigate DDoS attacks. So things like CloudFront, Route 53, application load balancers, WAFs, auto-scaling, as well as CloudWatch. Moving on to WAFs. A WAF is basically just a web application firewall. It's going to integrate with both your application load balancer and with CloudFront. It does not integrate with EC2 directly, nor Route 53 or any other services. So you're always using a WAF in conjunction either with your application load balancers or network load balancers and CloudFront. So do bear that in mind. If your EC2 instances get hacked, and this can be quite a popular scenario, what steps should you take? Well, obviously, it's been compromised. You want to stop that instance immediately. If you want to figure out how it's been compromised, you want to take a snapshot of that EBS volume and move basically go in, take a snapshot, terminate the EC2 instance, and then what you want to do is recreate that EC2 instance, not in your production environment, but in somewhere that's completely isolated, an isolated VPC with no internet access, so ideally inside a private subnet. And then you want to go in and access that instance and figure out how they hacked it. And the best way to do that is to use a forensic workstation. So you shouldn't just be using your main laptop or desktop because you don't know how they've compromised it. You don't know whether or not it could be some kind of worm that as soon as you RDP or SSH into the compromised server that your own workstation is compromised. It's always best to use a forensic workstation and then just go through and read through the logs. So it could be with Windows, it could be your event logs. With Apache, it could be any of your Apache logs, or with IIS, you could just read the IIS logs. Whatever logs it depends on the nature of the server, of course, but whatever logs that you are capturing, read through and see if you can figure out how the attack has happened. A lot of the time, it'll be something like cross-site scripting or having really bad permissions on like a WordPress directory, something like that. You should be able to figure it out. What happens if your keys have been leaked on GitHub? Well, you must, even if you've just had this up for like 10 seconds or 5 seconds or half a second. There are scripts or bots out there that all they do is scan GitHub looking for secret access key ID and access key ID and secret access key. So as soon as they see that, they will, they will send it to the hacker, and the hacker will have the keys to the kingdom for your AWS account. So even if you just put it up on GitHub for like 2 seconds, you must assume those keys have been compromised. After that, it's very, very easy. Delete the key from the user account, generate the new key, and then give those keys to the user and tell them not to be storing their keys in the code anyway. They should be using roles. Moving on to reading CloudTrail logs. This is pretty much, you're not going to be tested on it, at least not what I've seen, but you should have some experience in reading these going into the exam, and you should also have experience reading CloudTrail logs going into real life if you want to work as a security analyst. I did not see this in the security specialty, but in advanced networking, understanding how VPC flow logs works is essential to passing that particular exam, but did not see it in security specialty. It may be worth just having a quick look at how VPC flow logs work. It's completely up to you. Like I said, if you are going to work in the security industry, understanding VPC flow logs and understanding CloudTrail logs is going to be key to your professional success. Moving on to AWS Certificate Manager. SSL certificates renew automatically provided you purchase the domain name from Route 53 and it's not for a Route 53 private hosted zone. You can use SSL certificates both with load balancers and with CloudFront. They will be stored in Certificate Manager, but you will need to go and install them individually on each service. And you cannot export the SSL certificates from AWS Certificate Manager. It is a free service, but they do require you to use it on AWS infrastructure, and that's how they go and get their money back. Getting SSL certificates or giving it away for free. Moving on to perfect forward secrecy. So if you want perfect forward secrecy on your application load balancers or your network load balancers, you are going to need the ECDHE cipher. And in order to get that, moving on to perfect forward secrecy. If you want perfect forward secrecy on your Elastic load balancers, application load balancers, network load balancers, classic load balancers, whatever it is you want to call them, you're going to need the ECDHE TLS cipher. By default, you should probably just choose the 2016-08 policy. That is currently the latest one, and that will protect you for perfect forward secrecy. Just a reminder what perfect forward secrecy is. Essentially, with perfect forward secrecy, if somebody goes in and compromises your private key at a later stage and they've recorded all of the traffic to and from the client's workstation to the load balancer, they're not able to go in and decrypt what that is. So that's what perfect forward secrecy is, and by default, if you just use the default security policy on your application load balancers, it's going to be 2016-08, and you're going to get that ECDHE cipher, which will protect you going from that type of attack. Moving on to API gateways, so there's two things you really need to remember going into the exam is that throttling is available, and it is automatically throttled if you get too many requests. It's 10,000 requests per second, and that's really what you need to understand at a high level. If you are going to get, if it is being throttled, you're going to get an error message that says 429, and that says too many requests, error response back to the client. As soon as you wait for the next second, you'll get the next 10,000 available to you. Remember that this is an account level rate limit, and you can increase this by reaching out to the AWS support teams. So I think someone like Ticketmaster, for example, if they're building their front end in a serverless environment, they probably do need more than 10,000 requests per second. So they would probably reach out to the AWS support teams and get this increase. But if they didn't do that, what they could do is use API gateway caching. And this basically enables your API gateway to cache your endpoint's response. So with caching, you can reduce the number of calls made to your endpoint and also improve the latency of the request to your API. And when you enable caching for a stage, stage, API gateway caches responses from your endpoint for a specified TTL period. Remember, when you set up API gateway, you have these different stages. So you might have a dev stage, a test stage, a prod stage, etc. So you cache at this stage level, and like I said, you're always using TTL, so these are always measured in seconds. By default, you're going to have a TTL value of 300 seconds, which is 5 minutes, and the maximum TTL value for caching is 3,600 seconds, which is going to be 1 hour. And if you have TTL of 0, it means that caching has been disabled on your API gateway. So remember those two really important things for API gateway. It will be throttled at 10,000 requests per second, and if you are getting throttled, you can contact the AWS support teams and get them to increase it, or you can enable caching, and that should vastly improve your performance anyway. Moving on to AWS Systems Manager Parameter Store. So this is where you've got confidential information such as passwords, database, connection strings, license codes, etc., and you need to store it. Maybe your Bootstrap scripts need access to it. Maybe CloudFormation needs access to it, but you don't want to store it in plain text files on S3, which could inadvertently be made public. The best place to do this is using SSM Parameter Store. You can store the values in plain text, or you can encrypt the data. The cool thing about this is you can reference these values just by using their names. Like I said before, you can use this service with things like EC2, or with CloudFormation, or with Lambda, or with the EC2 run command, etc. Speaking of the EC2 run command, let's move on to AWS Systems Manager run command. So commands can be applied to a group of systems based on your instance tags, or by selecting those instances manually. In order for this to work, you're going to need two things. You're going to need the SSM agent to be installed on the instance. You're also going to need those instances to have a role, which enables us, Systems Manager, to talk to your EC2 instances. And the commands and parameters are defined in a Systems Manager document. Commands can be issued using the console, the CLI, the toolkits, for PowerShell, the Systems Manager API, or the Amazon SDKs. And the cool thing about this service is you can either run it on-premise as well as on your normal EC2 instances. So you can actually use this for on-premise servers as well. It makes managing your servers at scale a much easier process. Moving on to compliance, do go and check out aws.amazon.com/compliance. To be honest, there's not a lot of compliance stuff in the exam, but in the real world, these are the three things that you should definitely be aware of. PCI DSS, so for taking card payments. Just because Amazon's infrastructure is certified to a PCI DSS level does not mean that your application is PCI DSS compliant. You'll always need to do what's called a gap audit. So you need a QSA to come out and basically assess whether or not you're PCI compliant. You only need to be PCI compliant if you are storing credit card details. If you're using services like PayPal or Stripe or Braintree, then there probably is no need, because those organizations take care of that for you. But if you are storing credit card details, you will need to be PCI compliant, and for that you'll need to go through a process to get that compliance. I've worked with so many customers who have seen that Amazon's infrastructure is PCI compliant, so they just naturally assume that they're going to be PCI compliant by default. It doesn't work like that. There is a delta or a gap audit that you need to do. ISO 27001, 9001 are some good ones to be aware of. Again, just go check that out at aws.amazon.com/compliance. And for those of you in the United States, if you are storing any kind of healthcare information, HIPAA compliance is quite a big deal. AWS every day, or seems every week, they're announcing more and more services that are HIPAA compliant. So you can only use those services if they are HIPAA compliant, if you're managing people's healthcare information. Like I said, compliance surprisingly doesn't show up too much in the exam. The reason for that, I think, is this is a global subject that they're trying to test you on, and HIPAA, while very relevant inside the United States, has absolutely no relevance whatsoever inside of Europe, Africa, Asia, Middle East, etc., and Australia. They all have their own different standards. One other thing to be aware of is FIPS 140-2. This is government computer security standard, is used to approve cryptographic models. It's rated from level 1 to level 4, with 4 being the highest in security. And Cloud HSM meets the level 3 standard. KMS does not meet this, so if you see anything around FIPS 140-2, straight away think Cloud HSM. Do not use KMS because KMS does not meet this standard. And like I said, Cloud HSM is certified up to level 3. So that is it. You are at the end of the course. Congratulations. Do watch the summary lectures perhaps one more time in each section, just so you're completely ahead of everything. I really wish you the best of luck in the exam. In the next section, we'll just quickly look at how you can go ahead and book your exam. But congratulations, you've made it to the end of this course. If you do pass your exam, please let me know either via LinkedIn or Twitter or our Facebook groups. So congrats, guys. You're at the end. Let's go ahead and see how we book this exam.